Alright, this is the walkthrough for question 4 of the PE2 compilation, and this is the first part of our sci-tail cipher question. Right. So if we read through the question, we get a few things in here that will help us with our part A, which is to find M. Right. So the first one is that M is some integer larger or equal to n, right? And also it is a product of two primes, right? And primes here, they actually give us, later on in the question you'll see, they have a function for us to check if a number is prime. And we want the smallest m that satisfies this condition. We also see that by this fundamental theorem of arithmetic, this prime factorization is unique. So our m itself is actually unique. And so if we go to the question, we're going to be taking in a non-negative integer. So for here, we see that our input is a non-negative integer. Okay, and our output, we want it to be two values in here, P1 and P2. Okay. So we want a tuple of P1, P2, where P1 and P2 are integers as well. So a tuple of ints. And this has a few conditions, right? So we want it such that P1 times P2 equals to M, and that is greater than or equal to N, and we also want that P1 is less than or equal to P2. Yes, and I guess M should be the first number that we encounter this condition in, but that will be sort of guaranteed by our way of working through the question. So I think that's not that bad. In this case, actually the only sub-problem here, or the only thing that we have to figure out is just how do we find our P1 and P2. So it is just how to find P1 and P2. So I guess how to find P1 first, and then how to find P2. That's all there really is to this question, right? It is worth 2 marks. So the way that we're going to work through this question is also pretty simple. All we're going to do is start at the value n, right? So we have some m, and we let it equal to n, because m needs to be larger than or equal to n. So n is the starting point, right? Then from here, all we need to do is check, right? If we take our P1 all the way from, I guess if you want to start at 1, you can start at 1. If not, you start at 2. If you want to end at m, that's fine as well. There is some ways to make it shorter, but we're just checking, is P1 prime? And then from there, if we know that P1 divides m, then that will give us our P2 as well. So one thing that we know is if P1 divides m, then the result can, right, be P2, but not guaranteed. Okay, so that's what we'll try. So for P1 in range, in here you can start from 1, you can start from 2, whichever one you're more comfortable with. I start with 2 because it is the first prime number I want to start with. And you can end at m as well. In here, one thing I would use is that if we take the square root of the number, that is really the highest you need to go, because anything past that already puts P1 at larger than P2. right? So what I'll do is, of course, there will be some messy stuff that happens, but I will take the square root, the half power of m, and then because the integer removes our decimal points, I'll just add 1, right? If this is too confusing for you, just go with m, and we'll increment by 1. Okay, then for each of your P1, we just need to check, right? So does if m modulo P1 equals to 0, if P1 divides m, then we also need to check that P1 is actually a prime, right? Then finally, once we do that, we can actually check for P2 as well, because if P1 divides m, the result can be P2, right? So if we need it to be prime, then this solves our number 2 as well, right? M integer divide P2. P1, sorry. Okay, then if this happens, if these three conditions are met, so P1 divides m, P1 is a prime, and the result is a prime, we know by the by fundamental theorem of arithmetic, this is our unique P1, P2. Okay, so then we're done. We return P1 and P2, which is m integer divide P1. That's it. Okay, and if this doesn't happen, then what do we do, right? So if this fails, we look for the next, we check the next m. Okay, so all we need to do is m plus equals to 1. Well then, how do we make sure this goes until we find an m? We just put this in a while true loop. Because this return here will stop the function when we are done. Right? So all we're going to do is we're going to paste this into cosmology, and we're done. That's it. Okay, on to part B. Now we want to encrypt our message using this findM function. So what's gonna happen is in here, if you look at this, we will place our string into a table which dimensions are actually set by your findM function, which we will see later. And all we're gonna do is just take the strings column by column, and that will be our encryption already. So I guess a few things to take note of is that, let's say in the above example, right, we have C S 10 10 S. Okay. Now this has a size of 7, so find M will give us 9. So we're gonna have something like this. CS1010S. And then let's say our padding is the underscore as in the example, right? So in here we see that actually when we want to traverse this table, going from each index to the next row is just as simple as adding the number of columns there are, right? It's the same if, let's say, we have a 4x2, right? Going from 1 to 2 over here is just a +4, right? So we can actually use this to our advantage because we can make use of string slicing for this. Okay? So what do we want, right? Our input, as we see, is going to be a string, and it's going to be another string for your padding, right? This is your string to encrypt. And our output is just our encrypted string. Okay. So a few things, right? Subproblems. The first one is, what if our string needs padding? Okay. And I guess a symmetric problem is, what if our string does not need padding? Okay. So in the case that our string does need padding, it is actually a very simple, there's actually a very simple solution for that, right? It is just add string, add padding until string reaches required length. And this required length we know to be determined by findem. Okay. One more thing that we can note here is that findem is assumed to be working. So in here, do not paste in your own implementation of findem. Just in case something is wrong with it, use the one, if it is assumed to be correctly implemented, just use the function itself as is. Okay. So then from here, our second subproblem is piecing the string together, right? And this we saw from the drawing that we can access next row by going number of columns. Okay. So how will we implement our solution, right? To do this, first we will figure out the number of rows and columns. Okay. But this will be given by findem, right? If you look over here, the findem gives us P1 rows and P2 columns. So we unpack the tuple that findem gives us of length of message. And this will be our rows and columns already. Okay, so first we will run into subproblem 1. Right? Our string needs some padding, so we need to ensure that it works fine. What we can do to solve part A and part B at the same time is to do a while loop, right? While the length of our message is less than the rows times columns, right? Then what we want to do is just add the padding to our message. So message plus equals add. That's all, right? Then once we are done with this, we are guaranteed that our length will fit the dimensions described by findem. So then from here, what we want to do is start encrypting our message. So now we will initialize a result string, and then okay, if I go back to the drawing, right, what we can see is that we can start from the top, right, add this and this, and then we can go to the second one, add this and this, go to the last one, add this and this and this, and we see that the moment we are past this portion over here, we are actually done with the entire string, which means we can actually just slice like this, where the steps are the number of columns, and the indices that we iterate through is just 0, 1, and this is actually the number of calls minus 1. So we know we can iterate from 0 to calls. So then for I in range 0 to calls, then what we want to do is append to the string the message, right, that is sliced in this manner. We will start with I, we will end with the length of the message, and then we will slice in terms of the number of columns. This way, we get through the entire string, and then we can return our result. So if we copy this over to our encrypt over here, then we submit it. It works. So that's it.